David Smith here with another flipped classroom math video. A few tips before we start. Remember that you can speed up or slow down the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain. Lastly, you could turn on the captions and follow along with my words on the bottom of your screen. In today's lesson, we're going to talk about using the regression line equation for interpretation. So this is a little bit more abstract, but I promise you it's all the same stuff we've been doing in our current chapter. So check this out. First, let's take a look at the line equation real quick, just to reacquaint ourselves with what we've going on. This is in slope-intercept form, or gradient-intercept form. Y equals mx plus b, sure that's familiar to you. M is the gradient or slope, and that's the change in x over the change in y. The Greek letter delta looks like a triangle, and it stands for, in math and science, change in. So we've got delta x over delta y is our gradient. And then our b, that's the y-intercept. That's where the line crosses the y-axis, and it happens when x is 0. Now this can be, but isn't always, it can be an initial state of our situation when x is 0. So that can be a legit value, and sometimes it's not a legitimate value. So you just have to look at the situation, particularly if your y-intercept is a negative number. Many situations you don't get a negative output. So that's just a little bit of background on the y-intercept. Now, the slope, m, is what tells us the most about our situation. So check this out. So using it for interpretation, m, positive means we have an upward slope that's direct relationship. Okay, so as x increases, so does y. Direct relationship. If we have a negative slope, we have what we call an inverse relationship. As x increases, y decreases. Both of these are particularly valid. It's not like a negative one doesn't show up. There's plenty of situations in nature and in life where you have an inverse relationship between two variables. Right, we're going to finish this video with a scenario, a statistical scenario. We have an equation and we're going to ask some questions about it, starting with a couple true-falsers. So here we go. We've got a school survey that's studying hours spent watching social media compared to hours spent sleeping at night. So the x variable is how much time you spend on social media, and the y variable is how many hours of sleep you get per night. So that's what this is. Data was gathered, so we surveyed 100 people or 50 people, something like that, and we put that all in our calculator or our calculation tool, and we ran the linear regression, and we got this equation for our regression line. Okay, so I could write this way if I wanted to, minus 2x plus 50. And that's maybe more standard y equals mx plus b form, but those two equations are the same. So now that we have our regression line equation based on our data, let's answer two true-false questions. Now, I really want you to pause the video and think about what your answer is before you roll it on. Okay, the first one. The gradient, the minus 2, tells us that we have a weak correlation. Pause the video, think about it, come up with your best answer, and come back. The answer is false, okay? Now, pause the video and think of why. Why is it false? Okay, the answer is M only talks about the direction of the correlation and how steep it is, how much of a change in y you get for a change in x. But it doesn't mention R, it doesn't touch R, which is how spread out the data is. So you could have a very positive value or a very negative, this could be minus 200, but your R could still indicate a weak or a moderate or a strong correlation. So number 1 is false. Now let's look at number 2. The independent variable can't be 0. So to answer this question, you have to think about our reality, our scenario, and tell me whether or not the independent variable, remember independent is x, it's the thing you control. In this situation, it's the time spent on social media. So this can't be 0. Pause the video, think about that, and come back. This one is also false. Beep. Now think about why that would be false. It's very possible for x to be 0 because in our scenario, all that means is that you spent 0 hours on social media. Okay? So that's pretty good. So this is also false. You can spend no hours on social media, no problem. In fact, some people might say that's a good thing to do. Question 3. Now this is sort of a general prompt that you can get pretty mathematical about. It says interpret the gradient. Now that means this -2 number in our linear regression equation. So pause the video and think a minute about what that -2 means in terms of our situation. Our situation compares hours on social media compared to hours of sleep. Pause the video, think about that one. Okay, let's tease this out. Here is our gradient. M is -2 from there. This is the same as -2 over 1. And I did that particularly because remember, the gradient is the change in y over the change in x. So that means for every hour increase in social media time, there's 2 less hours of sleep. And that's what I put in words here. Every hour spent on social media results in 2 less hours of sleep. And that makes sense because here's my equation, starts with 50. If I spend 3 hours on social media, then I'm going to get 6 less hours of sleep. And that makes me think for a minute. This per night thing, probably not correct. You might want to just eliminate that. I'm going off an example in my book, and I think I just added that on the fly because 50 is not a good number for sleeping hours per night. You can't do that. So we're going to pretend like this is maybe per week. I'm just going to add that per week. One last question. Again, it's kind of, might feel a little vague. Interpret the y-intercept. So I want you to think real hard. There's a couple things you need to do to the equation first before you can interpret that y-intercept and say what you think it means. All right, let me give you a prompt. The y-intercept happens when x equals 0. Pause the video and think about that and come back. Okay, so what I did is I plugged in 0 for x. Remember, it happens when x is 0. So I put my 0 in for x. So it's 50 minus 2 times 0 is just 50. So that tells us 50 hours of sleep when there are 0 hours on social media. So that's pretty good. If you spend no time on social media, you're going to get more sleep. I went ahead and graphed that, and you can see here's my y-intercept. That's where the line crosses the y-intercept. That's 0 hours for social media. This is x and this is y. And that shows us that we get 50 hours of sleep. Now this line slopes downward with a slope of -2, showing us that as we spend more hours on social media, we're going to get fewer hours of sleep. I know I said the last one was the last question, but I thought of one more that's just as valid, just as good, and something you might see on a quiz or a test. So check this one out. Now you're being asked to interpret the x-intercept. Now remember, when it crosses the x-axis, y equals 0. So with that hint, you should be able to tell us what you should be able to interpret what the x-intercept means. Okay, I did the algebra portion of that. I set y equal to 0. 0 equals 50 minus 2x. And I solved for x, did that step. So that's 25. Now, tell me what this means in terms of the problem. Pause the video and think about that if you don't already have an idea. Okay, let's see what you got. This means that you're going to get 0 hours of sleep if you spend 25 hours on social media. So make a graph of that. Add that to the graph we did before. So here we go. You can see that when hours of sleep hits 25, according to our equation, when hours of social media hits 25, according to our equation, you're going to get 0 hours of sleep. So that's what our equation, that's what our scenario tells us. This is the last prompt, I promise. Interpret this situation in terms of the problem. Is this realistic? If you said no, you're correct. Even if somebody spends 25 hours on social media, they're probably going to get some sleep. Maybe they're going to sacrifice something else, but they're probably not going to get no hours of sleep, especially if the time frame for this is a week. So here's the thing about these equations. You've got to watch out for the intercepts because sometimes they make sense. Like in this case, the y-intercept made sense, but in this case, the x-intercept does not. Now you're going to come into some situations that are going to reverse that, or maybe both don't make sense. So you have to put on your critical thinking cap, think real hard, and answer those questions correct. Now that you've finished, take a moment to write down any questions so you can bring them to our next class and get some help. You can also watch the video again to improve your understanding. If you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.